Good morning to everyone present here. I am Debdeep, and I will start with our PPT without any delay. The problem that we have worked on is benchmarking. We have made a benchmarking tool which is comparing the stateful versus stateless filtering. So, what key parameters we are focused on? Our KPIs or key performance indicators include throughput, latency, CPU usage, and memory usage. Then we have the draft of the RFC that we have used. We have used RFC 9411 for making the benchmarking tool, and the methodology we have used from there. Then we have the supporting tools. The tools we have used are KP and Spark for traffic in simulation, and we have used for the tools for benchmarking and backend. Just a minute, I will explain this dashboard and then you can go to the next page. So this is the dashboard that opens on signing up. Before this, you create a lab, and each lab is the lab dashboard. Here are different nodes. We can on clicking on those nodes, these nodes are created over there. So this entire setup is just an for automation. So what happens here is, the first one is traffic source node. It's written is very small, so it's not visible. This traffic source node, one can create multiple such nodes. So the main motive behind creating this one is that if it was a linear thing, I mean there is no need of creating nodes. But let's say we are generating traffic from multiple such sources, or let's say we are not using one type of filter or multiple types of filter. So even for filters we have different nodes, which are basically pieces of codes that are running on the back end, and we can connect them with lines, and this entire thing will process do the processing, the analysis of the entire thing, and the result will be generated over there. Next page, please. So what are the specific problems that we faced while doing this? So we have used ML model for machine learning. For this is also our unique proposition from our end. So basically, this you can see, this is the graph that we got. This first one, red one is stateless and green one is stateful. So you can see over here, stateless is having a higher throughput than the stateful. So recent firewalls are all adapting stateful from stateless. So it's very important now to highlight how can we minimize this throughput difference. This we have worked on multiple optimizations, like we have used for CPU usage utilization. We have reduced them by using VMstat. We are dynamically extracting the packets and then the throughput actually, and then we are producing this graph. Then we have different solution plans mentioned. Tools designs are, we have basically, this is tech stack. So first we have used React, basically the MERN stack for our front end, and we have in the back end we have C programming for all the back end programs, and Python for dynamically routing this to the front end. Then we have used PDML for package generation, and iPerf for mainly network throughput calculation. And this test bed setup is inline mode. This everything is in dynamically done. So just as we are fetching the data, it gets dynamically plotted. So there is no, we have tried to reduce the latency created by the setup itself. Next page, please. Now we have this programming, that the small images that we have shown over here. The key matrices: throughput, latency, CPU, and memory usage. So here you can see this. This is actually yes. This is actually the latency. This is not visible over here. So this is step 1. This is step 2 and step 1 are simulating the packets. This is generating the latency, and then we have finally the output that is actually getting means done in this .txt file. It's dynamically going there, and then we have this finally this throughput, and then other calculations are being made. So what the new ideas that we have come forward with are simultaneously training and predicting the throughput based on other KPIs mentioned, and implementing caching mechanisms for stateful filtering to reduce latency for recurring connections. Next please. So what we have done, this is the pictorial comparison of latency. This is all of these are just average latency comparisons per second. It's difficult to plot all of them. Then this will also be huge pressure on the Python library. So now what is the new ideas that we are coming up with? First one is hybrid traffic benchmarking. So the RFC suggests us to use IPv6 and also to use TLS for cryptography for TLS 1.3 and more. But we have used TLS 1.2 for this one specific reason, that it's not suitable for all the systems. Most of the systems are still relying on TLS 1.2, and this is our next design that we have come up with. This visualization, we are plotting this dynamically, and these are the links to our interop testing. We have not done the entire thing, but we have run on couple of systems, and they are performing well, because this is based on the React and other projects which runs in all the systems. Next. So what are the lessons learned? First, let me talk about this. Below this, the graphs, there is a table of benchmark table which gets automatically extracted and gets input in this table. So these are the timestamp, state latency of stateful and then stateless, and all the comparisons are there.
This is actually a dynamic graph. Like for
yes.
Every packet which is coming is showing like that.
It gets entered into this table. So what are the lessons we have learned? We know stateful filtering is a resource heavy and with high churn and is susceptible to state table exhaustion. So so what are the various methods that we have come up with? 2 minutes left. Okay. So so let me just quickly move on to this stateful and stateless. Stateless offers faster throughput but lacks advanced analysis. So issues with RFC. This is the main reason I wanted to highlight to the audience over here. It lacks guidance on hybrid performance benchmarking that we have tried to incorporate in our project. Then we have the rigidity in test result validation. The things that are mentioned in the RFC are too much rigid, like this telling us to use quick protocol with TLS 1.3, and then we have this lack of support for emerging protocols, like ma'am mentioned this new emerging protocols for IoT based. It doesn't cover all of this in the RFC. So next slide please. So implementation guidelines, we have the benchmarking insights and the benchmarking inferences. This is just a simple thing. This is a stateful versus stateless CPU usage difference calculation percentage, and then we have the benchmarking inferences. How much high, how much less. So by using the machine learning model, we have seen that even though the CPU usage and the memory utilization increases by much, we didn't get much throughput increase. So our solution is that we are trying to decrease the CPU usage somehow, because in further future we'll have ML models, ML in this as well. So we are trying to reduce the other things, the CPU utilizations by VMstat and other by dynamic fetching all this data. And there are various trade-offs. Next page. So this is all for us. I hope we have completed in time. Thank you.
Thank you everybody.
Any question?
Quick question, when you're saying stateful and stateless, filtering of what?
Filtering of yes.
What traffic?
This stateful and stateless is basically means it's in front of the server, that all the packets that are coming from client to server, it acts as a packets are different means say some are TCP, some are UDP. Both type of packets are big.
specifically which one does this work relate to?
No, sir.
TCP
In
or
our
TCP?
in our system that we have developed, we have in that sense of system that you can develop a TCP data as well, and you can develop.
Have you understood my question?
Yes, yes, please.
In your RFC,
Yes,
when you say stateless and stateful filtering,
yes.
what does it refer to? UDP, TCP, both, or IP?
No, I mean IP, source IP and source destination. Those are the things for routing, for fetching the data and for all these things. But
You know
the
the-
packets.
You know what is an IP protocol?
Yes,
You understand that on top of IP you have UDP or TCP.
yes, yes.
Now
Also,
this filtering you are doing for IP packets, you are doing for TCP packets, or you are doing for UDP packets.
we are doing filtering for IP packets.
Yeah, so
Yes.
I have to ask you 4 questions to get a simple answer.
Okay, okay. Sorry.
Okay. Now, if you are going to filter IP packets,
Yes.
if somebody is doing HTTPS,
Hmm.
will it work?
For IP packets, we are actually doing it on port 80. We are actually trying it on HTTP only.
Understood my question?
Yes.
HTTPS.
HTTPS.
Yes.
No,
Will it work?
no.
So, what will you do then? Supposing most people are using HTTPS,
Yes.
how will this tool help them?
So basically, actually we have not done, but we can implement our design our benchmarking tool in such a way that it might act as a filtering for HTTPS as well.
How?
So that
How? That's encrypted.
yes, that's we need a decryption algorithm or something that decrypts that to then filter. Otherwise, it can't be done.
So most of the people, I mean,
Yes, HTTPS they use.
only very careless or very foolish people will be found using HTTP.
Yes, yes, yes.
So, therefore, how useful is your tool?
So it's not very useful in the as of yet for market. It's not market ready, but we
So forget about market is very far away.
yes, yes,
I'm
yes.
just saying conceptually also.
Yes.
How useful is it?
So its usefulness lie in the fact that we are seeing which is better in terms of packet filtering, stateful or stateless. That plot and that difference is what our tool, this benchmarking tool, is
Actually,
all
our
about.
problem statement was like that to
You-
compare.
You implemented the RFC correctly,
Yes, yes.
but how did you check whether you have correctly implemented the RFC?
So we went through the RFC lines and we saw that the standards rules that mentioned in the standards, we are following those rules or not.
Was it tested thoroughly?
No, not strictly thorough, because we have not implemented quick
How
protocol.
do we know it's correctly implemented?
So it's not completely built, but we have whatever we have done for HTTP, it's partially correct.
No, but
It's-
then the question is,
Yes.
why do you say that? So should I just believe you, or can you show me that I have done some tests? This is a systematic test that I have done. That is why, because I don't know if you have really implemented that
Yes. Yes.
thing correctly or not.
No,
You
yes,
have written a piece of software.
yes. Yesterday,
Whether that
there was-
correctly implements the RFC or not, you have shown some graphs.
Yes.
Are these correct? Are these
no,
not?
yesterday there
Because
was
once in
there was a session with the tech team that and the mentors that were helpful in guiding throughout this from the iPhone and others. They have checked our software and they have seen our codes like whether.
So you are saying that some other fellows have seen your code, that is why you think it's working correctly.
No.
No,
So say what you want to say,
no.
precisely.
Yesterday,
Beat around the bush.
yesterday there was a quick like on the tech stack and what we have implemented.
We cannot.
Honestly speaking,
Yes.
you
Yes.
have not spent much effort in testing it.
Yes.
You have built some GUI, as long as the
Yes.
GUI is getting populated,
Yes.
you are seeing some graphs, you are happy. But whether it is actually correct or not, you have not spent much time thinking on that question. Is that fair?
So we
Is
have
it fair?
we have read the
Assessment
RFC.
of you.
We have read the RFC, but to be honest, what we have
Everybody has read, but who has understood? That is what I want to know.
yes, what is what
I
had-
doubt nahi karungi you read it.
no, what is the implemented? We have actually not tested that whether it is 100%.
So you are going to
No.
become software engineers.
So we have tested this with real time traffic only, sir. We are doing it and then we are plotting it.
Okay, so let's get to the next thing.
Next week.